In this section, we'll be graphing systems of more than two linear inequalities. So let's take a look at the first one. We have 6x minus 2y is less than 8. We have 9x plus 4y is less than 8. We have y is greater than or equal to 0, and we have x is greater than or equal to 0. So this is a system of linear inequalities. Now, in the previous sections, we learned how to find the solution to a system of two linear inequalities. Those solutions are called unbounded, where the region where the shadings overlap continues infinitely in at least one direction. Now, in this section, we're going to be solving systems containing more than two inequalities, which yield what's called bounded solutions. Now, while the terminology isn't that important, noticing bounded and unbounded solutions is kind of important. So since we're going to be graphing, let's go ahead and make life easier by converting these inequalities into slope-intercept form. So let's start with the first one. We can subtract 6x from both sides. So we have minus 2y is less than minus 6x plus 8. Let's go ahead and divide through by minus 2. Minus 2. These two terms will cancel, which gives us y. We're going to have a greater than sign because we're going to have to flip our inequality since we're dividing by a negative. These two terms will cancel, so we have 3x minus 4. All right, so here is our first linear inequality in slope-intercept form. Let's go ahead and convert the second. Oh, excuse me. Let's go ahead and convert the second here. So let's subtract both sides by 9x. So we have 4y is less than minus 9x plus 8. And we can go ahead and divide through by 4. These two terms will cancel, which gives us y is less than minus 9 over 4 times x plus 8 over 4 is 2. So here is our second linear inequality in slope-intercept form, and these two are already in slope-intercept form. So we have our four inequalities, and we can simply plot them on a graph and see what's going on with their solution regions. So this is our y-axis, this is our x-axis. This is our positive y direction. This is our positive x direction. We should be very familiar with graphing these by now. We've done several of them. There's not a whole lot to it. We just find a couple points and we just connect the lines. We need to pay attention to the signs, the inequality signs. If it's a less than or equal to or greater than or equal to, it's going to be a solid line. These are going to be dotted lines, so we always want to remember that. Okay, so let's go ahead and plot some points. So our first inequality, when we plug in 0 for x, we're going to get y is equal to a minus 4. That's where the line crosses the y-axis. And it has a slope of 3, so we're going to go up 3 and to the right 1. All right, so this is going to be connected by a dotted line because we're not including any points on this particular line. It keeps going infinitely in both directions. So this is the line for this inequality. So let's go ahead and take a look at the next one. If we plug in 0 for x here, we get y is equal to plus 2, which is right there. That's where the line crosses the y-axis. And it has a slope of minus 9 over 4. So we're going to go over 4, 1, 2, 3, 4, and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right about here. It doesn't have to be perfect. And this too is going to have a dotted line because it's just a less than sign. So we're not going to include any point on the line for our solution. It is, however, going to go include in both. It's going to go in both directions infinitely. So there's our line for this inequality. Now we have two more. We have y is greater than 0. So that means y is greater than 0 means we're going to have a vertical line. It's going to go up and down. And it's actually going to go about the y-axis. If y was equal to 0, then that means we're going to have, it's going to be a horizontal line. It's going to be a horizontal line, so about the x-axis. So we're going to have the x-axis here and the y-axis here if our x is greater than 0. So in other words, our solution interval is going to be where this line, this red line, it's going to be above the red line. It's going to be less. It's going to be beneath this blue line, and it's going to be above or in the positive direction of the x-axis and the y-axis. So in other words, it's going to be in quadrant 1 and it's going to be this section, the small section right here. This is the interval of all values, and it's the solution interval for this system of linear inequalities. All right, now one more time how we got that. It's going to be above this line, it's going to be below this line, and it's going to be on the positive side of the x-axis and the y-axis, so in this quadrant. So it's just going to be this tiny little section right here. All right, this is actually very helpful and very useful when it comes to manufacturing and industry, quality control, and much of investments and finance. So we'll do several more of these just to get a good handle on them. So let's take a look at the next one. We have the system of linear inequalities. We have 3x minus 3y is greater than minus 9. We have x plus y is less than 3. We have x minus y is less than or equal to 3. And we have y is greater than or equal to 0. So this is our system of linear inequalities. Okay, so let's go ahead and convert these into slope-intercept form so we can more easily graph these. So we have minus 3y if we subtract 3x from both sides. We have minus 3x minus 9. We're going to go ahead and divide through everything by minus 3. These two terms will cancel. We need to flip the inequality sign to a less than because we're dividing by a negative. But these two terms will cancel. These negatives will cancel. So we're just going to be left with x plus 3. So that worked out pretty nicely. So that's our first inequality in slope-intercept form. Let's convert these two as well. So if we subtract x from both sides, we have y is less than minus x plus 3. That's our second inequality. If we're going with this one, we can subtract x from both sides. We have minus y is less than or equal to minus x plus 3. We're going to have to divide everything through by minus 1. These two negatives will cancel. These two negatives will cancel. We're going to have to flip the sign. So we have y is greater than or equal to x minus 3. And this one's already in slope-intercept form. All right, so we have our three inequalities here. So let's go ahead and graph these on a coordinate plane. Getting lots of good practice here. These linear systems of linear inequalities are one of the most helpful and useful skills to learn because we can actually use them in all sorts of real-world applications. And actually, we'll do some applications in the next section or two. Okay, so we have our first one. We have y is greater than 0. So we're going to have all the positive values of y. Just like we saw in the previous exercise, it's going to be all the values above the x-axis. So we can shade this entire half of the plane, and that would be y is greater than 0. It's going to be a horizontal line about y equals 0. Or, yeah, y equals 0. Okay, so let's go ahead and move on to the second one. We're running out of time here. So we have y is greater than x minus 3. If we plug in 0 for y, we get y is equal to minus 3. So it crosses the y-axis right here. And it has a slope of positive 1. So we have a dot right here. And it's greater than or equal to, so it's going to include all the points on this line. And we're followed by two arrows on the end. Let's go ahead and graph this one. If we plug in 0 for x, we have y equals a positive 3, so it's going to cross the y-axis here. It has a slope of negative 1, so it's going to go drop down 1 and go over 1. And this is going to not include, it's going to exclude all the points on this line, so it's going to be dashed. It's going to have a dashed line. It's just less than. All right, and we have one more. We have y is less than x plus 3. If we plug in 0 for x, we have y equals a positive 3. Again, we're going to have this point right here. These two lines are going to intersect right here, and it has a slope of positive 1, and we're not going to include the points on this line, so we're going to have a dotted line right here. Okay, so what's the solution region? Well, let's take a look. We have all the points on the top or above the x-axis. That's what we got from this inequality. We're looking for all of the values that are greater than this y is greater than x minus 3, which is this black line. So we're looking for all the values on this side of the black line. We're looking for all the values that are underneath this line. So we're looking for all these values over here and all the values less than this purple line. So what that's going to boil down to is this little region right here, this little triangular region. This is the solution interval for all the values that satisfy this system of equations, or the system of inequalities, excuse me. Okay, so we need to be able to realize, we need to recognize where the linear inequality signs are. So where we need to shade, we need to recognize the symbols. We only shade above where the inequality is. So like this black line, it's going to be everything above the x-axis. So we need to be careful with the inequality symbols, and notice this is going to be a bounded region. It's not going to be unbounded. So whenever we're solving a system of linear inequalities with more than 2 inequalities, we're going to have a bounded region, and it's this little region right here. These are extremely helpful. You can use them in all sorts of applications. We'll do a few more videos before actually looking at an application. So I'll see you in the next video.